So today we're going to test 3 vacuum pumps. One is a Chinese battery-powered pump, the second is a Chinese factory-made corded pump, both with 2 CFM, and the third is a 2-stage vacuum pump, also Chinese and factory-made. We are going to observe exactly how much time is required to evacuate a completely standard cylinder from a refrigerant canister using a vacuum gauge for the test. And there are 3 pumps in the test. Valia 115-N, a battery-powered pump, Valia VRP2DLP, and a Chinese no-name pump labeled ZL183, which claims it is 7 CFM. The plotted Valia is 2 CFM, but that's not entirely accurate. 2 CFM is at 60 Hz, and at 50 Hz it's about 1.8. The battery-powered one is rated at 2 CFM with a 5 amp battery, and this one claims 7 CFM. It's supposed to be half a horsepower, but it's practically weightless. There are serious doubts about this pump. So the cylinder is evacuated. I'll attach screenshots later. Right now it's at minus 1000 microns, roughly speaking. Now we'll release the vacuum and then evacuate with each pump. For the evacuation, we're using the 552A for test monitoring and a Revco 3/8 inch hose with 1/4 inch connectors. Also, there's a ball valve. I don't remember which Chinese manufacturer. So we're releasing the vacuum, dropping the vacuum. The oil has been changed in all 3 pumps. The oil was filled with Legam, the same type, and has just been replaced in all 3 pumps, even in the Chinese one. Let's start with our Chinese friends. The pump is brush type, very lightweight. Let's connect it. Install the battery using an adapter. I'm using Bosch with Makita adapter converters. For those who use Makita, there's absolutely no problem connecting this Lampas. Snapped it in, the batteries are charged. Let's see what this little guy can do. Here's the moment. Machine time. Let's see what kind of torque it will give, which we'll be watching. Here's the machine, here's the machine. What is time? Look right there. It is a small mini boat, which goes up to about 20 or 25 miles per hour. And then it suddenly drops down. I'm standing just like this, so it's clear what time means. Almost 10 minutes to reach 500 microns. I honestly wasn't sure they would reach that value. Let's see how many minutes it will take us. 4.5 minutes. Turning on the pump. And let's see the burst. I think that it increased by about 200 microns. At this point, it's not that important. Right now, we're checking the speed of reasoning. We approach it like this. The most important thing for us to consider right now is that a new partition has appeared. We are going to leave our current one in place, but we will also be testing a Chinese version from a very well-known factory called Valves on the supply chain. As for the component from Vasia's company that we got from the network, we are planning to break it off entirely, and I am leaving it to you to handle that task. In today's video presentation, we are going to explore and discuss in detail exactly what is currently happening across the latest developments in the global world of defense and the international security landscape. We reached a total distance of 20,000 meters within just 1 single minute of our fleet's time. In 2.5 minutes, we hit the mark of 2,300 meters. And finally, we reached 3,290 meters. At a total height of 4,270 meters. Once again, we also have various other lengths and specialized water carriers that we can readily manufacture for you. "150 meters, 100 meters, 26 meters. That was an absolutely incredible and amazing drop. And that's exactly how we are planning to execute it right now. We will move deep, like on a step, 20 meters. Almost 8.4 millimeters. It handles a steady drop confidently. It went below 400. You can look at the graph. The graph is in the cabin without the periscope. Those who use the skill at this level, when such a plan is not applied, that is, it still has duration. You move the arrow up towards the eyes and then wait for another 10 minutes to pass. It should be somewhere between 8 and 10 minutes. After that, the measurement then drops down to 12.5 millimeters. With these headphones, we reached almost 250 kilometers. The rate of drop is very weak, so I didn't make a separate video about it. You will need to completely reset the system now, turning everything off entirely. So with that done, let's move right on to our very next client. See? And right here in this section, I showed you with the specific block the shooting block, which was successfully changed in just about 4 seconds. Once the air has completely stopped being sucked into the system, let's proceed to remove the valve. Since the pump provides the power, and the accumulator is in an inconvenient spot, the saline meter and the additional valve are now turned on directly. The pump was powered by a 5 amp battery, which can run on a standard one or can work for 50 minutes on a 5 amp battery. I have a Bosch adapter installed, the regular one. Well, regular in the sense that it's sold by the same seller as the pump itself. A Bosch Expert battery was purchased, which replaced the standard one. These are reinforced high-power batteries. Let's see what it can do. The battery is charged to 60%. I think that will be enough for 15 minutes, maybe even more. It's unlikely we'll be vacuuming for more than 15 minutes. So let's turn on the battery. Set up a new measurement. Turning on the pump. Pressing start. The pincher doesn't want to work. Press start. Open the screen. Opened it, but after this step, it should give us a better vacuum in less time. So I turned it on there, just as the manufacturer claims. One thing to note is that it's much quieter than its corded counterpart. In 1 minute and 40 seconds, we reached 20,000 microns. Now let's see what happens next. In 2 minutes, we reached 10,000 microns. In 2.5 minutes, 5,000 microns. In 4 minutes, 23 seconds, we reached 1,000 microns. And in 6.5 minutes, we reached 500 microns. Let's see what we can actually achieve, what ultimate vacuum we will get. The maximum measurement time is 15 minutes. The measurement videos show a 10-fold decrease each time. At 7.5 minutes, it's 4.6 microliters. The vacuum depth indicated on this vacuum display is 23 microns. You will see 23 microns when I turn off the vacuum display at 7.5. Once we reach the 12.5 minute mark, the measurement sits exactly at 200 micrometers in size. This value is very deep for the system in terms of timing. In real conditions, achieving this is extremely difficult. According to the standard protocol, it's 500 microns. In Germany, no one suggests reaching 200 to 150 microns on the system. After 14 minutes, we have 180 microns. And we think that this is most likely its limit under real conditions. And so, after 15 minutes, we got almost 170 microns, which is a very good result for protocol testing. Let's look at the holding. I'm sure there will be hold. Moreover, this isn't a fully operational system, just our setup for testing. the battery is at 20%. It's silence. So what do the results show us? You've all seen the test results? They are quite decent. The Chinese pump surprised me a bit. Series of instructional videos, I am going to explain in great detail the various external factors that affect the vacuum's performance, its ultimate depth, and its overall duration much more significantly than the actual specifications of the vacuum pump itself. If you found this video interesting, please like, subscribe, and leave a comment. There will be a lot here about air conditioners, about tools, about the specifics of installing and repairing air conditioners. See you soon.